Oh, okay. I think the data is flowing, the stream is streaming. Stuff is happening. Okay, I have the chat open. I can see the chat if you write something. I also see Telegram. So, yeah, glad you were all back on board. I have my t-shirt. It's here. It's kind of affordable. It's not much more expensive than just a regular t-shirt. So we could make a shop also for people to buy this. As soon as we have a really cool product, I guess. That's a requirement. And the t-shirt does not say the kind of product, so I'm still flexible. I can make the trading bot or the image recognition or anything else. The t-shirt will still be applicable. Yeah, so here is the algorithm I made over the weekend. NPM2 money printing machine 2. Oh yeah, it's not gonna work. It's so blah, blah, bombastic and blah blah. Who knows if it's gonna work? It doesn't matter. Of course it matters, but it doesn't matter for my strategy. The strategy is to make the algorithm and try it out. It doesn't matter whether it will work. It's just what I want to do right now. Maybe it works, then we're happy. If it doesn't, we do something more complicated, or we skip the whole trading bot idea. We will see. Love the shirt. Thank you. Yeah, it's kind of okay. I wanted black at first, but black is stupid because, I don't know, the logo has so much black in it already. So I settled for this. They shipped it really quickly too. It's a great website, shirtinator.de. Very recommendable. Well, I have to wash the shirt also and see how well it survives that. Okay, so yeah, well, let's check out the first algorithm maybe. I actually forgot what the first algorithm did. Yeah, it had much more classes and much more overhead and everything. It was able to close positions, but it didn't have any way of opening positions in an automatic way. So this class here, I wanted it to be super short, like no classes unless we need them. Like just the raw algorithm as short as possible, and it really turned out very short, 122 lines. And it uses raw arrays wherever possible. I made my own names for the floating point types. So double and float is what we used, what we actually use, but in the code I write real or price. Real is inspired by Pascal. Back in the day in Pascal, floating points, before even floating point coprocessors, were called reals. So I used this from real numbers, use this word again. Because I can replace things in JavaX. So price, the only point where we use float is for the raw ticker data to save some space, and because a crypto price doesn't need double precision. But within the bot itself, everything is double. So here as a Java class and here as a primitive. So sometimes it looks a bit funny. Real adversity. So yeah, so this is like the minimal version. Also the minimal version in terms of an algorithm that could possibly work. I think this is the simplest trading bot algorithm I can imagine that could actually work. That was my reasoning. So yeah, let's go through it a little bit. The only thing you put in, not the only thing, but the one thing you put in is just a ticker, which is the history of prices, and we can just drop all the prices that don't change. If the price stays the same for 20 entries, we just compress them into one. We only need the changed values. So thank you, Aditya, for the comment. Yeah, yes, so we put in the historic data, and we need to put in the market properties, like of the platform we use. And I actually put the slippage and the fees in one value, which I think should work. And I call it adversity. So this is relative to the price change. So if you have a price change, I make everything relative to the crypto price change. If the price change is 1%, plus or minus, doesn't matter, then we subtract from that the fees and the slippage. Slippage meaning if I want to close the position, I will not get the price that is current. I will get some slightly worse price for reasons. So that's a bit harder to calculate, and it will probably depend on how volatile the market is, but we try to get away with an average. And we also put the fees in there, and the fees can actually be calculated just this way. Like on the platform I use calculates fees just this way. Even with leverage, it doesn't matter. The fees are just one fixed percent value relative to the current price, which I don't even know which one it is. The fees are usually 0.0, it's very small, 0.25%. I have to look it up, but this is one value we have to put in because it also changes the way the bot operates. If there's more adversity, if it's harder to make a profit, certain trades will not be made. So this has to be put in advance. So that's the market object. The position object is what the bot creates. Positioning with an opening time and a direction, plus or minus. And the two intelligent parts are called the juicer and the eye. So it came up with new fancy names. I love fancy names. So the juicer is the closer. The juicer milks the pig, as I said the other time. So if the position is open, the juicer figures out when to close it, and you tell it how much loss you allow and what the pullback is. So there are only two values, two parameters for the juicer. And they are once again relative to the crypto price. Same scale. And the eye is the opener. It looks at the cryptograph, and you put in the history here, and based on the history, it will advise whether to open a position, meaning it returns 1 or -1, or if it returns 0, it advises not to open a position. In the ticker class, it's just this area of prices plus a timestamp, because we want to cut off the history at some point to simulate the decision at that point. We don't want to cut an array every time, so we pass the array, which is unchanged, and we say which time in the array we are looking at, and you can ask at the current price, and you can ask at a price back in time from the current time. And this is what the eye algorithm uses. And eye is abstract, and the implementation is called simple eye, which is once again the simplest way I could imagine for this detector. And it just goes from the current point in time, it goes back a fixed amount of time and looks up the price there, and it sees how much the price has changed from that time to now. And if that difference is bigger than this here, which is once again a percentage, then it says open a position. This is supposed to detect these runs, these big changes. So we obviously don't know what these 4 parameters are. This adversity parameter we can more or less guess. It's easier to guess, but these 4 parameters we just don't know. But that's the point of the optimization algorithm that we run first. So it will just try a lot of values and see which one works best. And that's what I want to do today. This is just a convenience method. Opening price, this calculates the opening price of a position. This calculates the profit of a position at some point in time on some market in percent, as always. This here asks the juicer when to close the position. This actually goes forward in time until the juicer says, okay, close, and returns the time when to close. So it incorporates the pullback logic and the loss tolerance. This is another convenience method. What does it do? It finds the closing time suggested by the juicer and then gives us profit at that time. And this is a little, we have to find the juicer parameters first. Oh, you're following, that's good. We have to find the juicer parameters first, because only if you know how how you handle an open position. Only if you know how profitable an open position is can you decide when to open a position. So we make the juicer first, and then we make the I for the juicer. But of course, it's a bit of a chicken and egg thing, because how do we test the juicer if we don't know when to open positions? So we do a bit of a approximation there. Actually, I just try random points in time and just open position there and see how profitable it is. So this is what this does. It takes some point in time, it takes the juicer and tries both a short and a long position at that moment and sees which one of those works the best. That's our theoretical profit. It's not a real profit because we have this magical guess in here, whether it's short or long, but it's an indication of how good this juicer is. Because some are going to be, with some parameters, it's going to be really bad, and with some parameters, so because if you make these parameters too high, both of these, if these are very high, if both of these are 0 or greater, they're never negative. If both of these are too high, it will never close positions, because the loss is never reached, and there's never enough pullback to close. That's obviously a bad juicer. And if the values are really small, positions are closed instantly. So somewhere in between these extremes, you have the optimum values. So this is what I want to find. I'm not sure if it's in any way like a linear, or I don't know how crazy this function will look if you plot the profit versus the parameters. If it's like some kind of smooth curve, or if it's crazy fractal, I don't even know. We will find out, I guess. Yeah, so we make this juicer with an approximation, and we can store different values that work well, and can also try these second best, third best juicers with, in the second step where we make the I. But we have to get started somewhere. And this class backtest it tests an I and a juicer together with our history of prices. And the clue is here that I don't go through. I want to test every time within this time range, historic time range we have, but that takes too long. So I just test random points in time, and I have these averages that will get more precise. So the idea is I can mix different searches. I can make 20 different juicers and run these backtests in parallel and see which one is the most promising, and that one I follow more. And if I have more time, I also keep calculating the others, or I can keep calculating everything until this iterator has given me all the points in time. So it's just like an optimized search. Profit. We're calculating the profit for each position, and we also check how many positions are actually open and closed. So if this is close to 0, we know that there's, I don't know. It's just interesting to see, I guess. And the I can be null. So if we want to just test the juicer, it will do this approximation thing. Or we can test them both together, and then we test the complete bot, basically. That's something I want to change here. Wanted to change here, I think. Here we see how many positions are opened. If it's not opened, then we just return. So this number actually is only the closed positions out of the open positions. But I think I want to have this number like the absolute number of closed positions among all the positions. So I'm going to change that a little bit, and then we can hopefully test it. So test only juicer. Juicer. So here, just have to change the logic a little bit. So we say this is null. Here we set the profit. And we go to this branch every time. So if the I set don't open, then we will have a value of 0 here. Yes, and this is okay, and that's okay. Yep, I think that should do it. And recompile. And reload. Okay, evaluate the first juicer. I did something here. Let's see what I did. It's already 2 days ago. We make, yeah, NPM module, we make our market module. I set adversity as 0, just to start with the easy stuff. And I already tried a few values, I remember. Yeah, I tried 0.1 here. These are the 2 parameters for the juicer. We should do something about these ugly long names. Can I actually rename a class in my scripting language? I think I can. Let's try if I can. Let's see if I can. I think I can actually do that. So npm2, just assign the class and then use this shortcut. I think it works. My language is quite flexible. Hey ho, yes. Okay, it ran actually the full backtest. The backtest is an iterator, so you can get these ever-improving averages in a list or something. Okay, so in the beginning it has tried nothing, so it's 0. Has tried the first point in time. We get this first profit average. It tried the next one, and it goes up and down. And it converges to some value. The changes get smaller and smaller because we have more values averaged. And it doesn't even take long to do all of them. I think this price sequence was 1.4 million entries or so. But if I condense them and just, this is what this function does, it removes identical values next to each other. It only ends up being 90,000. So most of the time, we're getting values 4 times a second, but most of the time they don't change. Yes, the new size is 97,000, and it started with 1.4 million. Yeah, and yeah, I used to worry about these slightly different values because we get like 5 different values every time, which are slightly different, but I think we shouldn't worry about that. The point of the bot is to find big moves. And if there's a big move, it doesn't matter if you have a really, really small difference. These are actually spot prices, I think, and the future prices on BitCat are a little bit different once again. They also take in prices from other platforms, but once again, this doesn't matter, I think. This shouldn't matter. There should be a robust bot for big price movements, not a bot that tries to make micro transactions for micro changes where the fees become really important and the slippage becomes really important. If you have a huge move, then none of these things are actually important. Wow, let's make these classes shorter here. It looks so much better. Wow. So this one too. Like this. There. Oh, I have to return in here. Yeah, so this is the profit for this 0.2 loss and pullback. And if we try something like 0.1, we get lower profit. So 0.2 is obviously better. Even higher here. But let's see what happens if we have a really high value. It's even higher, but maybe it's misleading because we have this market adversity really low. What if I do 0.1? Yeah, it goes down. Okay, I didn't know that these high values actually, okay, it goes higher and higher. That's interesting. Maybe it's misleading because we only test the juicer and not the whole thing. Maybe we actually need to test both of these at once, so to have realistic results, because this assumes we always know which direction to open a position in. That's probably misleading. Because right now it looks like if we make this really large, we get best results. That's probably not true. Okay, with large values, it gets slow because it takes so long to close a position. Okay, let's show some more stuff here. Okay, the profit per position is only updated when actually position closes. So yeah, it's still calculating here. I think I have a 60-second timeout. So it will probably time out soon. Yes, it does. Yeah, and that also means probably we won't have many close position. I mean, we have this nice feature. We can just take a few values. And it should be a lot faster. Let's try that. Yeah, taking the first 10 is fine. And now we can show all these values, I guess. So profit per position, positions opened, etc. I kind of want to improve my autocomplete. If I put the type in here, okay, there I can't use the short type. What if I use the long type? If I add this type declaration, which shouldn't be necessary because I'm just creating an object of a known class. Oh, okay, then I get an autocomplete. That's cool. Didn't know I made this. That's good. So I have partial autocomplete. What does this commented out code do? For opening time, closing time. Oh yeah, I was showing the breaklines. Some kind of debug stuff. Let's delete for now. It's in the history. Okay, let's put in some stats. Oh, nice. The autocomplete is cool. I should put more autocomplete in my language. Makes coding a lot easier. Okay, positions opened, percentage, and closed percentage. No positions opened and 60 positions, what? Oh, 60% closed. Yeah, but wait, there's something wrong. So I is 0. Oh, we don't update this if there's yep, okay, whatever, that's fine. Okay, 60% of these 10 positions were closed. That means some weren't even closed because we reached the end of the timeline. We only have this one timeline we'll work with, and if it doesn't close, if it doesn't close before the timeline ends, yeah, we should probably put this into the profit, right? If it never closes positions, that is not a good chooser. Because the timeline is too short, it may mean that we just ran out of data. But it should be long enough for most positions to close. How do we factor this into the profit? Good question, actually. Let's show some more stuff here. Chooser, tested. Just the chooser. Okay, it shows us parameters. That's good. I tested. I should be 0. Oh, we don't even have the value for this. Let's put in the variable. I is just null. Okay. What if we put realistic values again? Yeah, if we put smaller values, all the positions are closed. Yeah, there should be some punishment if it doesn't actually close most of the positions. I'm just not sure how to put that in. If there are a few that are not closed, it's just because they're near the end of the timeline. But if most of them are not closed, it's some kind of problem. How do we figure this into the profit? Could at least say it's profit 0 in that case. Not sure. Okay, 0.3, 0.3. Oh, this time we actually get minus. That's interesting. Yeah, because we have adversity here. So yeah. Actually, if the I is null, then we don't need this opened positions at all. If not null. Right. And we say non-nulls here. Okay. That's it. Okay. Yeah, what do we do with these unclosed positions? Maybe profit 0 is a good first idea. Okay. And date. At some point we have to zip our ticker files, for sure. Okay, now if I try these really big values again, the profit goes down. N is 10, so every position has contributed a value, so we have these zeros in there. It should bring down the profit at least a little bit. Because profit 0 is not very... Yeah, we should probably have a negative value here to really make sure that that's not a good case. We'll see about that later. Yeah, I want to make some random numbers, but not in a linear scale, I guess. I was thinking about logarithmic random numbers, because here we're not sure which scale this really is, although we are kind of sure. It's probably not 0.01 scale, and 1% is too much, so we could have, yeah. I still want to make these random numbers exponential random numbers, logarithmic random numbers. I will explain in a moment if you don't understand. Random log, I have never made this, I'm sure. Random exp. Nope. 1 second. Let's make some new project. Let's call it math experiments. Here, there we go. Like if I say random, I get a random number. And I can also say, yeah, different things here. You can say random from min and max, or just from maximum. Random 10.0, I get floating point values between 0 and 10. But my idea was to make a scale that is, what's the right word? Logarithmic or exponential? So we start with 1 or something, and we multiply. Now we can just use powers. For I to 10. Right, these are powers of 2, but if I don't want 2, but something smaller, like this, I get numbers which are 30% bigger every time. So with this number, we can decide what the factor is between two numbers. And we can also go negative, of course. And count iterator. Yeah. Go from -10 to 10. So we have like 20 numbers or whatever. And each of the numbers has a factor of 1.3 over the last number. So we can decide how fine, how granular we want it to be. Yeah. This is if we want to kind of cover a large range of numbers and still be fairly efficient. So the small numbers have small differences and the big numbers have bigger differences. And the whole thing is still like a fixed list. We can also go floating point. And we have infinitely many values there. Yeah, if I go floating point, actually maybe I don't even need this factor, I think. I would just say random, minus 10. No, wait, yeah. Okay, let's think about it. I make a random number from minus 10 to plus 10. Okay, and then I use my 1.2 value and I just say power 1.2 with this. That kind of works. I get small numbers, big numbers. I'm wondering if this value even matters anymore. Because if I say power of something else, how do powers work in math? How do powers work in math? If I have a to the power of b, if I do something to the a, well, let's start with the b. If I do something to the b, b plus 1 is what? That's a to the power of b times a to the power of 1, right? Plus in the exponent becomes multiplication here. That's how exponentiation works. So if I add something here, I get a factor in the result. What if I do something here? If I say 2a, the power of b, that is it's this, right? To the power of b times a to the power of b. Yeah, should be this. So we have the same value as before, this here. And we have this in front. Yeah, I'm not sure where this is leading, but my idea is there's possibly only one of these curves. If you make it continuous, you don't even have to specify this, because this is a ratio between two subsequent numbers, but if it's all continuous, it doesn't matter. Well, we could go with this this version here, I guess. Yeah, I'm not completely sure here. Yeah, I just want to make enough random values so we cover the interesting values, the best values. Try not to make too many values that are too big or too small or generally pointless. So I think I can just go, I just have a minimum. Let's say the minimum value we're interested in is like 0.01. And the max value is like, let's say 10%, because that's probably too much already. And then we have the logarithm of each of these. It doesn't matter which place I use for the logarithm. Log min value. Yes, and we have logarithm of max value. Yes, and now we just make a random number between min value and max value. And then we take the exponential of this. Oh, add function, okay. I think this will give us exponential numbers between 0.01 and 10. I think that's just the way to do it. Unless I'm missing something. We will see in a moment. Thanks for the comment. Yeah, I mean, see, Let's say we take a number of these, like this. Yeah, we get all the values here. 9 is close to the maximum, and sometimes it should be close to the, yeah, 0.09. 0.01 is very close to the minimum. This looks just like what I wanted. Let's make a function for that. That sounds good. So we had random here, and then we have let's ask Java about randomizers. I think there's an interface for randomizers. Let's check quickly. There's this random class, which is the old class. Yeah, since Java 1.0. Aha, we have random generator as an interface. Okay. Okay. Okay, we have lots of implementations of this. Secure random is also there. Or actual cryptography. Jumpable generator. Okay, random generator, good to know. Well, let's make a simple version first. So we make exponential random. Not a good name, but good enough. Random number generator with exponential distribution. So what was the formula? X of random of log min and log max. Okay. Exponential random min max. We could also try to find all 4 values at once. The question is just, is it gonna find the good values quickly enough? Also, we can vary things. We can do genetic optimization. Like if we have one result, we can try a very slight variation of the parameters and see if it works better or worse. I've done a lot of this stuff actually. Vary and random. I've made a lot of classes for this, but I was usually not happy with the software architecture, but I have something like this. It makes a random instance or varies an instance. I did some genetic optimization using this for some project somewhere. Yeah, it can probably be done. Okay, where are we? Yes, it works. Fine. Good. Bye. Okay. We could try this, just optimize both at once, actually. You can just do a test here. Like, I also has two parameters, which were, what were they again? Time and move. So time is in oh, that's a bit of a problem. Remember, I took out all these plateaus. I took out all the values that don't change. But if I want to go back in time, I need to know when the value changed. So like this is not really going to work. I need something like, I need to actually store the timestamps too. So right now this doesn't really make sense unless this is a ticker with constant intervals. Let's put the timestamps back in. We have the ticker sequence thing. We can use this, or we can stick with these arrays. Yeah, why not use this one? Let's put the remove plateaus thing in here. Remove plateaus. Unless we keep the timestamps intact. Yeah, but let's make a new object here. Okay. Remove plateaus. Pretty simple function. Okay, we have, okay, it's doubles, not longs. Yeah, no, we just make a new ticker sequence. So new ticker sequence. This, and let's say we copy some stuff over. Market name. And then we go through all the entries. I know get methods here. I should be get methods, get price. And get timestamp. Like this. Yes. Try, yes. We just store the first timestamp when the plateau began, I guess. Here we copy one value, and then we move forward in the array until we hit a different value. Yes. And then we return, and that should be that. Files, that's good. But it's in the library, I think, so I have to recompile the library. Yay! Recompiling is always great. Okay, let's recompile everything here. Boom. Uh, phone is making some noises. What is it saying? Uh-huh. Uh-huh. Nothing important. Yeah, we need these timestamps. Once again, what is my phone doing? Telegram, new messages. Yeah, thank you. Not in the important group, though. Okay, still working. Compilation done. We could put this all into the ticker sequence thing, but this is in the library, so it always needs a complete recompiler. It's not so good. Yep, just a little maintenance here. Timestamps. This is kind of the same as the ticker sequence class, but yeah. Here we need the binary search. Time is the index in the array, actually. That's different. Let's say call it length, actually. The first linked items. Okay. Oh. We have these two versions, ticker and live ticker. Ticker is historic data, and live ticker is live data that's coming in. And we can add new prices at any time. Okay, almost there. Resize array. Needs more types. There. And yes, new ticker. Okay. We still need the binary search though. Let's call it time from end. No, wait, what do you call it? Yeah, this is in the timestamp scale. Okay, timestamps, binary search. Uh, and we need to wrap it as a list for this particular function, although we could, yeah, no. This Java library function needs a list, not an array. But we have stuff like that. One that we want. This is slightly inefficient. Maybe we can find the most efficient one, like this one here. We do the same for a long array. Oh wait, we have what? We have it? Nope. So we want this one here with longs. Long array. Long. 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 Boom. And I forgot one. Did you notice? I forgot this one. Good. Long areas list. And we look for time value. Current price is actually just the last, that's pretty easy. Data of length -1. It's the last value. Yeah, we also need the current time actually in this live ticker. These plateaus make it a bit difficult. The whole logic. So we may be moving forward within the plateau. We need some extra value here. It doesn't have, yeah. Long current time. Yes. Yeah, no, okay, that's how it works. Time is current time. Here, current time. Yeah. Let's see. Yeah, maybe. Why is stuff always so complicated? Okay. Okay, almost there. Yes. Not iSeal, but long seal. And then, okay. I want to round to to round up to a long. Huh. Round up to int. Round up to long. I think it's just like this. Long. No, I see what. Oh, LC. Okay. It compiles, which doesn't mean everything, but it means something. Oh, we didn't define the I shortcut. Nice. I. Yep. Yeah, now it requires the timestamps. So we have the ticker sequence. Remove plateaus. Yeah. That's the shortened sequence. If we check out the timestamps, we get some jumps. We should get some jumps. Hard to see like this, but I think it should probably work. Oh yeah, let's check out the last timestamp. Last timestamp was this 1664 and 550 at the end. And after we remove the plateaus, we get something similar. I think that's good enough. It's probably correct. Okay, now we have the plateaus removed and the price array, and then we have the timestamps array. And we put both into our module thing. Okay, problem. Oh yeah, new I is of course wrong. Yeah, we need min move. And okay, what's the minimum move we want? We maybe want 1% of movement. And our time range is now in milliseconds. So we have minutes to milliseconds. Let's say 1 minute. What? Oh, not I, but simple I. Implementation is called simple I, of course. Okay. Simple I. And we need the abbreviation up here. I. Aha. Okay, profit positions opened 0, so it didn't open any positions. But we only had tested like a few entries. Let's say we test 100 times. Let's say we test 1,000. Okay, yeah, I mean, it's okay, I guess. Is it? If only 1% of all the timestamps are opened as a position. It's maybe okay, so backtest. You'll probably note the positions that are opened. Let's go to 10,000 because it seems fast enough. Run. Seems really fast, actually. Okay, it seems to consolidate. With 10,000 tests, it still has 1 point something percent positions opened, and most of these are also closed. And the average profit is negative, so we're not great. Juicer is kind of nonsense. We have this nonsensical large value juicer thing. Okay, profit is getting better. What if we go down here? If you have a very nice market, okay, our positions get close to 0, but it's still negative. That's interesting. So maybe we'll always be in the negative. Who knows? Who knows? Who knows? Yeah, we can get it very close to 0, but not 0. That's interesting. How's that happening? Yeah, I want to see the positions opened and closed for sure. We have the position object. If we test the I also, we have the, yes. We don't have a class for closed position, but we should make one. Closed position. Let's say we put the position in and yeah, we use time in different meanings now. Yeah, confusing. But anyway, closing time. Yeah, we need this object here, closed position. Mm-hmm. Closing time. Uh, position. Market. Yes. Like this. And we just add, yeah, close positions. Sure. We just note all our positions that were actually opened and closed. Closed positions. Boom. Mm-hmm. Closed positions. Just yeah, autocomplete. So nice. Okay, interesting. So we have 112 closed positions. We could show these as a candle graph, right? Let's save the last back testing and some variable save or set object variable. Can I serialize these? Serialize? No. Set transient. Last backtest is backtest. We can visualize this in some way. Right, put it for our last backtest. There we go. Those positions. Let's take any one of these. Okay, there's our closed position. It's a short position, as indicated by the -1. And it was closed pretty quickly from 2122 to 2124. We do need the timestamps to make this work, actually. Um, we can put the ticker in there, I'm sure. Hmm. As multiplication, these things here could actually go into the ticker class, etc. This is timestamps. Stuff like this. Nope. There needs to be some refactoring here. But anyway, float long int undefined. Float long int. Yeah, it's a bit dirty. No, don't fail again. Oh, come on. But that should change. The last function should take so also int there. Okay. Yes. Hmm. Hmm. Wait, what? Here? Where is this used? Oh. Okay. This needs to go here and then this. Okay. And update. Okay, still the same data. Yeah, but now we can get all the information out to visualize this. For example, we get the whole ticker thing. So we know what to display actually. How does the candle view work again? Draw candles, trading candle painter. Yes. Let's see. Okay. So we need the candle size as always. Maybe go with 1 minute. We make this candle maker. And yeah, we have too many different classes for the same thing. We convert back to a sticker sequence. Oh, double array. What is this? Timestamps. And we have a candle maker, and we add this, that. But we only show the part we are interested in, I guess. Hmm. Hmm. Yeah, that's our closing time. Hmm. Okay, that's a timestamp. Closing timestamp. And we need the opening timestamp. Yeah, okay. An opening timestamp and a closing timestamp. And we want only the candles, including this range. How long was the position open? It was not open for long, I guess. It was open for 787 milliseconds. That's a bit short. Strange. Why was it closed so quickly? That's extreme. Well, let's check it out. Okay, so okay, duration. Mm-hmm. Yeah, I want to round with the candle size. So size minutes to milliseconds. Yes. And then we the opening time. We need some special rounding function here. Round. Yeah, this divide and no, that's not. Oh, round down to, yeah. I want to round down to a certain length, which is the length of the candle. Yes, that's it. Round down to, okay. Round down to this. And let's say we show one more candle. The end time is basically rounding up. And we add one more. Show one more candle to the left and to the right. And then we need to cut out this portion of the sequence. For sequence. Yeah, we need the search method here. Index of timestamp. It wasn't so hard. Just need to rebuild the system as always. So we need to take a sequence. Index of timestamp. Start time. And then index of end time. And then we make a subsequence. Why is everything so complicated? Subsequence, start index, and index. And then we'll visualize this. Easy, easy. Why is it closing the position so quickly? Interesting. It doesn't even take that long. The library is compiled. Now it compiles the main program. And we're almost done. Yeah. It's already updating. Okay. Oh, it's called data instead of prices. Oh, great. Declare data. Okay, to double array not found. That's bad. Where is my function? To double array. That's another conversion method. Boom. Yeah, but then I think it should run, I guess. Hey, what? What? I just changed this here? What? Huh? Nothing to update? I just changed the function there. It must be something to update. Okay. No. I know what's going on. Do a double array. Okay. Oh, okay. Good. So we have 3 candles. That's as expected. So the position is within this little candle here, which doesn't really make that much sense, I think. And we should see some numbers here. How big the candles actually are. I'm almost tempted to just draw a number here. Or we make some lines in the background. Yeah, that's actually an idea. So here's our painter. And yeah, we just draw something in the background. First, we know our vertical and horizontal range. So yeah, we have a black image. Draw percent lines. Draw candles. So actually we just go through the vertical range. Min max. We have some setting here. How many lines we want? I'm thinking 0.05 is nice. Percent align. Distance. How many lines are drawn? indicate percent changes. We could calculate the percentage from the middle. We need to base our percents in something, so. Thanks for the comments. Percent. It could be fancy and make the percent relative, like make it exact in each step. Actually, kind of funny. Let's get to be simple for now. Whatever percent step is range. Can I ask center of range? I can probably do this. Yes, I can do this. Center of vertical range. Percent line distance. And since it's a percent number, I need to do something like times 100. Quick draw a line. G. Can I draw horizontal lines? Wow, let's see. Horizontal line? No, I can't. And I have to round this value to an integer. So just from 0 to, yeah, that's easy. 0. This to full width. And we need some color. Let's say we use color gray. So why not? Oh, what is Y range? Oh, that's defined below. So let's move that up there. Okay. Should actually just draw the lines now. I think. Diagram. I think it's closing positions too quickly. Why is it closing here within this one candle? I mean, but it's going to, it has spikes, right? So it went up and down. So it may be that the spikes just were big enough to close the position already. Okay, only have one line down here, so the whole thing seems to be within 0.05%. Let's check out the live ticker. We have a live ticker, right? Where is it? Here. Oh, it's only one line also. I'm guessing the calculation is probably wrong. Let's check out the real live ticker. Oh, we're on this large increment. Okay. Yeah, it's actually not moving much. It's a slow period. So compare this to this. It looks the same. It's good. And it actually is very small. 0.2%, and it's barely touching 0. No, wait. What did I say? I said 0.05%. Oh, you notice what I did? I multiplied the percent value with 100. Of course, I should have divided by 100. Yeppa. Mistakes happen. I'm waiting for the auto start. Yeah. Oh, see, now we have something better. That's good. That's a lot more informative. Each of these is now 0.05%. Cool, cool, cool. So, run this one again, and that's very many. Yeah, we should generally, maybe you should go to 0.1, I think. Painter. Yeah, look, if I put this here, get autocomplete. But it shouldn't be necessary because the type is already clear. Painter, percent, line distance, 0.1. Okay, that's half as many lines. That's better. Okay, this indicates that this was actually a time of a lot of movement. Interesting. Oh, it was a short position, actually. Oh, yeah. Maybe it was just a pretty bad position. Okay, there was a short, it went down a lot, yeah? And the algorithm said, okay, now we get in. But maybe then it moved up again. What if we make the candles smaller? Just 0.5. Interesting. Let's make it even smaller, 0.25. 1. At some point we should get more. Wait, what happened? What? The duration of the position was only 787 milliseconds. Something must be wrong here. Something is wrong. This optimization with removing these plateau values, it's making everything complicated. Stuff would be easier if we just had this constant intervals. Just 4 values per second, and that's it. Let's check out some other positions. Let's say we use a random position. Okay, this position is way longer, for example. Okay. Let's check out some random positions. Oh, once we had 4, so one of these were open longer. Interesting. Okay, image, and let's show some data with the image. Example, the duration. Okay. Yeah, finally a position that was held for 17 seconds. It seems really eager to close positions quickly. What is our parameters? What are our parameters? 0.3 and 0.3. Maybe it's not enough. Profit. We should be. I should have a link to the mother object here. I think this should work. Yes. That's fine. This. Yes. Okay, update. Now we can get the npm object. Ask for the profit. Now we need some more data. We need to store the market. Or we just store the profit actually. Yeah. You. Yeah. The position should store its own profit, actually. Yeah, okay. Okay, see. Oh, one good one here. Profit 0.2125. Interesting. So basically here stuff went down, right? And then the system said, okay, we get in and we make a short position here. -1 means short. And it continued to go down. So this was actually a proper position, but it is also closed in 10 seconds. So it's very eager to close positions quickly, I guess. But yeah, it's pretty cool actually. Okay, let's save this as a script. Show context of random closed position from last backtest. Cool. Yeah, this is one that didn't work. Also one that didn't work. Many of these don't work currently because we don't have the right parameters, I'm sure. And maybe our eye is too simple. The eye just looks at one, goes back, you know, you saw it. It goes back a certain time and checks for price movement. We maybe need to go back different amounts of time and check for movement in each of these, like some threshold for each interval. And that's complicated enough to find the right points in time. Well, we can definitely run some. Yeah, sometimes there's profit, and we already have adversity built in. I set the adversity to 0.1, which is fairly realistic, I think. So I'm already factoring in fees and stuff. Yeah, our average profit is very slightly in the minus, but it's not a catastrophe. Seems like we're close to actually having a profit. We'll see. Yeah, we need to do the actual search for the parameters. I just put in parameters manually here so far. So that's probably something we could still do right now. I think the actual algorithm is working fine, even with all this complicated timestamp handling. I think it's actually sound, probably. Maybe there's a bug there, but I think it looked quite reasonable from the candles that we saw. Yeah, we should also show the position in the candles, right? With the arrow like we had before. And we can see where within this candle actually the position started. Yeah, let me think for a moment. I just need to put this here. Yeah, we should show the position. I think I put this in here. I didn't translate it to Java all the way. This needs a little bit of tweaking, but it should be possible. I mean, yeah, let's try this quickly. Positions, what kind of object is it? Trading position. Oh, this is the complicated one. Well, all we need right now is just Time price, yeah, closing time, closing price. And the relative value. We could make an interface out of this. That's kind of a good idea. Or maybe, I don't know. Or we just use this class. Here's visions. It doesn't allow for white positions. They're always either green or red. Okay, that wasn't too hard. Yeah, okay. Now what? Which class did we use for the position here? Draw candles with position. I mean, this really has a problem. This trading position thing doesn't have an opening time. That is clearly not correct. That definitely needs to go here. Opening time. I think long is what we want. A timestamp, we use timestamp, I think. Doesn't matter, let's stick with long and closing time. So that should be better at least. Yes. And relative value. Expected P&L, also known as relative value. One more fixed. Okay, is open. Ongoing is open. Somehow we came up with different names for the same thing. Is open is the same as ongoing. Yeah, I must have made up different names. Different times. Okay, that's at least compilable. Right, okay. Yeah, maybe we can make this work. Trading position. Just have to create an object. Okay. Positions, add new trading position. And then we put in all the stuff. Opening time is actually called start time here. No, it's not. It's called opening timestamp. Closing time is closing timestamp. Opening price is position, I think this. Closing price is position closing. Price, no, or yes or no? No, actually no. Closing time. It must be in the profit calculation, ticker of time. The class, all this stuff got a little messy right now, actually. So whatever. Needs some refactoring. Hmm. Mm. Hmm. Oh, okay. I need to go to the, yeah. There's a naming conflict. Whatever. Okay. Now what? Come on. Okay. PM2. There. Now you compile. You, no. Ah. Okay. Real. Now you compile. I command you to compile. Okay. Good. Good. Now we should get the closing price. Closing price. And last thing we need was expected P&L, but it's actually calculated. Mm-hmm. Let's ignore this for now. It's going to have the wrong color, but I don't care, actually. Let's just try like this. To do... yeah, let's just run it. Null pointer exception. I think I know why, because list of positions is not initialized. Yeah, it's going to have the wrong color, but the position itself should be painted. Need to calculate this opening price. There. 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 It works. Opening price not found, but there we are. Okay, it's a little arrow within the candle because, yeah, let's what if we have basically 6, what do I want to do? 10 second, I want to do 10 second candles. Okay. That was a bad position. Only 8 seconds, they're so short. Uh-huh. Interesting. Yeah, that was a good one. No, why? Why was it a short? Does that make any sense? They should be really short candles now. Like actually 10 seconds. Yeah, we need to optimize the parameters, of course. So we'll have different backtests running. This we could put in a separate script. This shows the backtest as a human-friendly thing. Let's make a script out of that. So show backtest, render backtest here. So render function render backtest. Backtest is all this stuff. And we can ask the backtest for the juicer, I think, I is backtest I. Boom. Okay. And let's try to call that function from script 182 render backtest. We need to put in what? Wait, what? User not found in backtest. Why not? Backtest. Oh, it's called J. User is just called J in this object. How fancy. User is backtest J. Backtest. Okay, user. Save. Okay, that still works. That's good. So we shorten this. Okay, let's make a copy of this one and let's say find best. Let's maybe do both at once. Just juicer, yeah, juicer and the I at once. Best juicer and I. I like my fancy names. So this we just keep, it's all the same stuff. Just the data preparation up until here. Yeah, this also. And here we just start these, put in these random values. Maybe we do simple random values here. Like, a reasonable maximum is like 10%. And the smallest value is probably something like 0.05. So let's say max value is 10. And min value is like 0.05, maybe less even. How many different values is this? 10 divided by 0.05 is 200, right? Is that 200? Did I save this here? Not sure. I should put this in the script. Here. Okay. 10.0 divided by 0.05 is 200. Yes. Wow. So we have 200 different random values for each parameters. That's kind of okay. Yeah, def random value. So we just make an integer and we multiply with the min value. Let's try this. Okay. Yeah, I think that's okay. It may also make zeros, I think. Yeah, it's probably good enough. It's going to generate a lot of stupid combinations, but we just let it run for a while. So. The reducer gets a random value and another random value, and the I gets a random value here. And why is this always popping up? And for the time, okay, that's a different kind of random value. What's the scale there? Nobody knows, actually. That's actually the thing. But that's why I wanted these exponential random values. Because then I don't have to know the scale. Did I make them properly right now? I did, actually. So let's try this one. Exponential random. And the time. We do the same thing here also. Then we don't need the min value. Let's do that. Random. This is for the percent things. Exponential random. Wait, no, it does have a min value. Yeah, it has a min value and a max value. But we could then make it even smaller, actually. Okay, let's try this. Exponential random values. So in time, min time, max time. This is in milliseconds, so I mean, 1 second is definitely already too low, I think. or let's say seconds to milliseconds. And here we say 15 minutes maybe. Let's test out the function. Okay, let's show it in minutes. 2 minutes. Yeah, so 16 minutes. Why is it so much? 15 minutes? I said the maximum is 15 minutes. Why is it? What is this? That's not correct. Wait. It's not very precise. I only do like 100,000 steps in this randomizer, but still. What's about the other one? That one is better. Make small, big value. That one is fine. This one I'm not happy with what's happening there. Let's do it in seconds. That's easier. Oh, what am I doing? Do you see this? 1,000 seconds. I meant this. Okay, now it should be better. Yes. Okay, 0.01 minutes. That's fine. 11 minutes. Okay, that's all good. Okay. So this goes from seconds to milliseconds. Time. Okay. Here we can select how many positions we test. Okay. So, but it doesn't take that long. So we can decide how precisely we test each of these combinations versus how many of them we do. 10,000 should probably be plenty. We are taking 10,000 timestamps out of 97,000, so almost 10%, that's fine. More than 10%. That would be enough to evaluate these things. And our evaluation is profit per position. Yeah, let's make a score function. No, I can do that next time. Get. No, actually, this returns this also. Take first. We do 10,000 steps, and then we return the profit. Okay, profit is changing. That's good. And basically, we run this in a loop and always show the best one. We should go to the user interface right away. So best profit. Okay. Why not make it a little bigger? Yep. And now we can say, while this is showing, do the calculation. It's something like calculate continuous, something like this. Calc continuously, yes. Yep, that should be that. Calculate continuously. When the label is visible, we run something, and that is this code. And later we could also show the actual juicer and everything. Oh, time almost up. Okay, but we're almost there. So score is this, and we just set the score. We render the score, I think. And this is our GUI. And let's go. Okay, it's just showing the latest score, not the best one. Okay. Interesting. And some of them take longer than others, it seems, because some of them close positions quickly, and some of them close positions never, so they're really slow. So, of course, we didn't want to show the score, we want to show the best one. So, new best. Best is new best. If best put like test score, then let me show the new score. Okay, wow, look. We found one with profit 0.11. We found one that is making, we found one with 0.2. Oh my gosh. Wow. Oh, 0.4. We still have to check whether that's actually true, but they're a bit bigger. And we can format it properly, format level to X. And maybe we could try to show the best one. So visualize object. I think I broke something, namely everything. North. Yeah. So here we have our profit. and ignore the ugliness here. But this should show us, yeah, this shows us the best juicer actually, and the best eye. Also a bit hard to read, but okay, what does this look like? It looks like we need much higher percent values. So the juicer needs to look for a lot of loss, like 8% loss and 2.6% pullback, and the eye needs to look for 2.6% move, and this time interval is E8 means milliseconds, so we have E5 is seconds. Yeah, let's do this one. 3.8 thousand seconds, which is, that's an hour. Interesting. So it seems an hour is a good time frame. I was thinking it would be smaller, like these mega runs are like a few minutes. Look at 5 minutes, but it seems here that an hour is a good time frame. Apparently, according to this calculation. Nice one, right? It did something. We have to verify whether that's actually a usable result, but I have to say it's not looking like it's complete garbage. I mean, it's not looking like nonsense. Also, this one here, what is this? 0.09, so a move of 0.1% in an hour? That doesn't look right, actually. There may still be problems, bugs or something. It's opening 94 positions, okay. And many of them are not closed, so that's not right. Yeah, the juicer is bad. It should basically close all the positions, otherwise it's not right. Okay, this is not really correct, I guess. But we're getting close to this. Yeah, we need to make sure positions are closed. Half of them not closed, that's not okay. That's probably misleading. Anyway, but it's late, right? So we almost got it done today, what I wanted. Guess that's it. Here, that's the shirt again. It's cool, yeah, I hope it survives washing. It's the only concern I have. Okay, thanks, Lydia Dream Team. See you tomorrow, maybe, hopefully. And yeah, thanks. Yeah, see you tomorrow, hopefully. Thank you. Bye-bye. Sleep well.